Imagine spending an entire year in space, 365 days of silence, darkness, and endless motion above our planet. No fresh air, no rain, no smell of Earth. Only the hum of machines and the vast blackness outside your window. You float weightless, orbiting Earth every 90 minutes at more than 28,000 kilometers per hour. From this height, borders vanish. The whole world looks fragile and blue, a thin shell of life surrounded by emptiness. But while the view is beautiful, your body is quietly falling apart. This is what happens when a human lives in space for a year. In 2015, NASA astronaut Scott Kelly began a bold experiment. He would spend nearly a full year aboard the International Space Station, while his identical twin brother, Mark Kelly, stayed on Earth. Together they became part of the NASA Twins study, the most detailed look ever at how space changes the human body. By comparing two genetically identical people, scientists could measure the true cost of life beyond our planet. When Scott first arrived on the station, everything felt strange. Without gravity, simple tasks became challenges. Water formed floating spheres. Food drifted away if you let go. Even sleeping was confusing, no bed, no up or down. Yet the most dramatic changes were happening inside him. Within days, his muscles began to weaken. On Earth, gravity constantly pulls us downward, forcing our bodies to resist that pull. In space, that resistance disappears, and muscles atrophy rapidly. Astronauts must exercise for nearly 2 hours every day just to slow the loss, but even then, they return home physically weaker. His bones suffered too. Without gravity's stress, bones start losing calcium and density, up to 1% per month. That's 10 times faster than osteoporosis on Earth. The calcium released into the bloodstream can even cause kidney stones. Imagine returning to Earth after a year and realizing your skeleton has literally become thinner. Then there's the heart. In zero gravity, blood no longer pools in the legs, instead, it floats evenly throughout the body. The heart doesn't need to pump as hard, so it gradually shrinks. When astronauts come home, they often feel dizzy or faint because their cardiovascular system must relearn gravity all over again. Fluids drifting upward cause the infamous moon face. Astronauts often feel pressure in their heads and sinuses, and many develop vision problems. NASA calls it spaceflight-associated neuroocular syndrome, SANS. Some astronauts' eyesight never fully returns to normal. Yet despite the physical strain, Scott continued his mission. Each day brought 16 sunrises and 16 sunsets. From the cupola window he watched lightning storms flicker across continents, and the thin blue line of Earth's atmosphere glowing in the dark. He often said that from up there, our planet looks both beautiful and heartbreakingly fragile. But while Scott looked down at Earth, scientists on Earth were looking deep inside him. They drew blood, collected urine, and even analyzed his DNA. The twin study revealed something astonishing: space affects our genes. Radiation levels aboard the ISS are more than 20 times higher than on Earth. Constant exposure triggered changes in Scott's gene expression, some genes turned on, others off. His telomeres, the protective caps at the ends of chromosomes, temporarily lengthened in space but shortened rapidly after his return. It was proof that spaceflight can influence the fundamental blueprint of human life. Other systems also went haywire. Scott's immune system became hyperactive, reacting to harmless substances as if they were threats. His microbiome, the bacteria living in his gut, shifted dramatically due to diet and environment. Even his cognitive performance changed. Reaction times slowed slightly near the end of the mission, likely from fatigue and isolation. Isolation itself is one of space's greatest challenges. The psychological strain of being separated from family and confined to a small metal habitat is immense. Astronauts often report feelings of loneliness, anxiety, and insomnia. Communication with Earth takes seconds, but emotional distance feels endless. Birthdays, holidays, and life events happen without you. Outside every window is the infinite void, silent, beautiful, and terrifying. Maintaining mental stability becomes just as important as physical health. Despite all this, Scott Kelly's mission was a success. He conducted hundreds of experiments, maintained the space station, and proved that humans could endure long-duration missions. When his capsule finally re-entered Earth's atmosphere after 340 days, he had traveled more than 230 million kilometers around the planet. But his return wasn't easy. The moment gravity hit, he felt heavy and dizzy. His muscles ached, his skin burned. He compared it to having the flu combined with a bad hangover. It took months of rehabilitation before his body felt somewhat normal again. The insights from his year in space changed everything. Scientists now understand that microgravity, radiation, and isolation all interact in complex ways. These findings are guiding preparations for humanity's next big journey, a mission to Mars. Unlike the ISS, a Mars voyage could take nearly 3 years round trip. The crew will face higher radiation, total isolation, and no quick rescue if something goes wrong. Learning how to protect their bodies and minds is crucial. To solve these challenges, researchers are testing artificial gravity habitats that spin to simulate weight. They are developing new exercise equipment to maintain muscle and bone strength, and radiation-shielded spacecraft using water or hydrogen as protection. Some scientists are even exploring genetic engineering, tweaking DNA to make future astronauts more resistant to radiation. It sounds like science fiction, but the future of space travel may depend on it. Meanwhile, space agencies continue to study astronauts aboard the ISS to monitor long-term effects. The data will shape medical protocols for deep space missions and could even help people on Earth. For instance, research on bone loss in microgravity is already leading to better osteoporosis treatments. Space science doesn't just explore the universe, it improves life here at home. After his mission, Scott Kelly said something profound: "The more I look at Earth, the more I realize how small and precious it is." Living above the planet for a year didn't just change his body, it changed his perspective. He saw no borders from space, no wars, no politics, just one fragile world that we all share. And that may be the most important lesson of all. A year in space proves that the human body can adapt, that the human spirit can endure, and that our curiosity knows no bounds. Every challenge teaches us something new about what it means to be human, and what it will take to live among the stars. So, what truly happens to the human body after a year in space? It weakens, it struggles, it transforms, but it also survives. Our muscles may fade and our DNA may shift, but our determination remains unbreakable. The next time you look at the night sky, remember that somewhere up there, humans are learning how to make the impossible possible.